Sorry, let me adjust my voice. Hello humans. From far away, stars are tiny points of light. But up close, stars are massive, seething fiery balls of burning gas. This fierce display does not last forever. Eventually, the nuclear fusion which powers the stars will burn all its fuel. Gravity then collapses the remaining matter together. For very large stars, what happens next is a display of extremes. First, the star explodes in a supernova, scattering much of its matter throughout the universe. For a brief moment, the dying star outshines its entire galaxy. But once the light fades and darkness returns, the remaining matter forms an object so dense that anything that gets too close will completely disappear from view. This is a black hole. A black hole is formed when a sufficiently large star runs out of fuel and then collapses into what we call a singularity, which is a single point containing all of its mass. We don't know what happens at the singularity because the theories we use to explain the physical world, namely Einstein's theory of relativity and quantum mechanics, both break down at this point. The gravity of a black hole is immense that anything close by is sucked in, never to escape, not light, not particles. Nothing at all. The boundary around a black hole beyond which no light or other radiation can escape is called the event horizon. You may ask, if not even light is allowed to leave this particular area, how do we really study them? Well, there's this kind of irony of black holes that are black and invisible. But they're also some of the brightest objects in the entire known universe. And the reason is, because when you tend to get too close to a black hole, if you're a planet or a star cloud of gas, you get whipped around into a really fast orbit going nearly the speed of light, heated up to millions of degrees and shining out in bright ultraviolet, X-ray, radio, just really bright sources of light coming from not the black hole itself, but from the effect that it has on anyone who gets too close to it. So that's how we see them and study them. How big a black hole is, you may ask. Black holes come in different sizes. Some are small and some are huge. The stellar black hole is formed when the collapsed core of the star is at least about 3 times the mass of our Sun. Black holes can grow by taking in more matter and merging with other black holes. A supermassive black hole has the mass of millions and millions of our suns. Scientists think there's a supermassive black hole at the center of every galaxy. The one in the middle of our Milky Way galaxy is an impressive 4.3 million times the Sun's mass, and it's called Sagittarius A. Once an object crosses the event horizon, its only possible future is to go to the center of the black hole. So what happens if you fall into a black hole? If you fall in a stellar black hole, then the force of gravity on your feet would be millions of times the force of gravity on your head, and it results on you being ripped apart to become a stream of matter. This process is known as spaghettification. If you fall into a supermassive black hole, the difference in the gravitational force between your feet and head would not be as pronounced and you would remain intact for longer. However, there is the theory that at or in the vicinity of the event horizon is a massive firewall which will incinerate you as soon as you encounter it. Until next time, word of the day is spaghettification.